Okay, I'm recording now. So for you can go to lab files. Okay, for today's class, all for Blender, I will discuss. If we have time today, we'll talk about Blender. If we don't have time, then I will dedicate 1 or 2 labs or 2 sessions on Blender. Okay. Uh, right now, I just want you to download this. Go to lab files and December uh, one folder. Download the folder as it is. So download the complete folder. I want everyone to do that now. And extract that, extract all. So to December 1, so this is going to be today's folder, December 1, and December 1, click on that. So I have the perspective camera. So first we are going to look onto the perspective camera. So once you download this and extract, you are having, so this JS is not, this is not for today's exercise. That's fine. Styles also, we are not using any style sheet, but this 3 folder has the 3.j. I mean, that is the 3.js library we have. And now this orthographic camera exercise, we have 3 exercise. Okay, open that exercise. I mean, open perspective camera first. I mean, how do you open? Right click, open with Chrome. So by default for everyone, you should have this scene. Okay, are you able to see this? I'll wait for 2 minutes. Just download that and open perspective camera, and I will just give you 2 minutes. Okay, what is the question? Okay, I'm here, Professor. Okay, Jeremiah, I will mark your attendance. Don't worry. Okay, just open this file. Just I'll be back in 2 minutes. Just make sure that you download and open this file. So we are going to start working on this. Okay, just let me get me some hot water, and you open this. I'll be back in 2 minutes. Okay, so if you have opened the file, you should get a clear like that. Okay, so let's examine this code. Okay, um, which is I think it's perspective camera exercise. I think this was a file, right? And let me open that. Okay, so here you can read it's all in one single file. So I created the geometry material. I have the geometry material, and then I'm creating a sphere, and then geometry and material, we have a plane, and then there we have a cylinder. We have 3 objects in the scene, and this by now you should know how this code works. So there is no question that people don't know the code, because you can read the code, you can understand this code. Okay, one thing we obviously we are using was the camera, right? For the camera, so this is Without camera,
Ooh. Oh my gosh.
okay, without
Thanks.
without camera, we don't see anything in the scene. So we have created this camera. So so camera is the perspective camera. You know how what is perspective camera, right? So perspective is example is tool, rail parallel lines, right? Where rail roads will converge at a point, so which will have a three-dimensional, basically uh, three-dimensional view of the object. Everything we see in the world is perspective, so we don't see in orthographic. What is perspective view? The nearer of the object, the it is going to be the nearer the object, the larger the object is going to be. The farther the object is going to be so smaller, right? So here I'll just use whiteboard. So the thing important about perspective camera is um, we have already dealt. Uh, um, I have spoke about view, frustum several times. So so the thing is, I just want to. So here there is a camera, right? We have a camera. So this is our camera, right? Camera is there, and so this is the camera we are placing in the front of the scene. And here it is like we know what is view frustum. So in the view frustum, we have this is my far plane, and this is my near plane, right? And this one is called as the FOV. So this is the field of view, okay? And you have to mention the near. So anything which is beyond the far plane is not going to be visible in our scene. Anything which is uh, um, less than the near is not going to be also visible. So this is a field of view. This is measured in angle, okay, degrees. And then also we have to have what is called as the aspect ratio. Aspect ratio is nothing but this is scene I just want to draw. So this is like aspect ratio. uh, Aspect ratio is width by height. So these are the four parameters you want to give uh, to the perspective of this thing, right? So here you have let camera. So what are the things? So here I'm talking about perspective camera. So let camera is equals to new, and this is going to be three dot perspective camera, right? So three dot perspective camera, you have to write three dot perspective camera. By default, all your files have included camera. So without camera, nothing is, you cannot see anything in the scene, okay? So so the first parameter for the perspective camera is the field of view, and the second one is the aspect ratio, which is going to be as I said, is width divided by the height. This is going to be the next parameter to the perspective camera, followed by the near plane, and then followed by the far plane. So these are the four parameters for the uh, basically the perspective camera, okay? So the given code we have set, if you see this code, we have set it. So let's go to the code. So we have perspective camera. So here we have the field of view is 75 degrees, and inner width divided by inner height. So width divided by height is going to be our aspect ratio. Our near plane is going to be 1, and the far plane is going to be 1000, okay? And then we have to setting the position for the camera. So the camera is set at position x is equal to 0, and y is equal to 10 and 40. And also I have added some light, spotlight, and then added that light to the scene, okay? So these are the parameters that we are uh, interested to look at, right? Okay, now so you can see this is the camera position, and let me just go and show you here. So you open this, are you able to get this are you able to get this scene?
Yes.
Yes.
Okay, very good. Now go here and go to more tools and developer tools. Okay, and this is the error is there because the style sheet is not found, so the error is there, so don't worry about the error. So it is not important right now. So let us query the spear position. So the spear position, yes, open this. You know how to open this, right? So it's a more tools and developer tools, right? So it is going to be there, and scene dot sorry, not scene dot spear. So you want to know the location of the spear. So spear, if you enter, so it is going to, why I'm not able to get spear. Spear is SPH as capital. No, it should come with the, so it's okay. I was playing, it was working. Here it is giving different options, so let's not worry about that. Let me just console. How do I clear it? Clear it. Okay, now let us spear. Let's try to spear dot position. It's recognizing. Okay, spear is coming, right? If I say it's spear, it's, you know, it's coming. Spear dot position. Okay, it's not just spear. If I say spear dot position, is going to give the position of the spear here. So spear dot position. Okay, -5 and 5 and 2. So let us move the spear to z is equal to 30. So dot z equal to 30. Okay, so if I move the spear to 30, so spear is at location this one. So if what happens is so the spear is coming in front of the camera. So the, you can see that spear is coming in front of the camera. So spear, you can see that we are moving the spear in front of the camera. So you have that we have moved the spear. So because it is coming to the near plane, right? So spear dot position dot. So let me go to the code. XYZ. Okay, so camera is set at this position. See, camera is set at 40th position, right? So we are moving the spear in front of the camera. So I just mentioned that it is going to be spear dot position dot z is equal to 30, right? So if I move further, let's say 38, and it's you or 40, the spear will not be seen, because as I said, anything less than the near plane is going to be invisible. Is that right? So here we are not seeing the spear. So let me just go back and spear dot position dot z is equals to, let me just put to the original value. Original value was 2. So let me move back the spear to the old position. So we are going to move the spear to the old position. So this is the one. Okay, so you can change like that and see how the spear is moving in with respect to the camera. So see, camera we are placing at this location. So camera, see, the camera position is set. Camera dot position dot set is equals to 0, x is 0, y is 10, and z value is 40, right? So if I move the spear in front of the camera, you are not going to see. So we have to move the spear further away, so from the camera. So then we are having the spear in the proper location. Okay, so that is one point I just want to tell you. And so what happens if you set the spear to, so this is far plane. Where is the far plane? The far plane is basically you know, at 1000, right? So let me just give at let me just try this as well. So spear dot, so -900. See, you can, the spear is moving farther away from the camera because it's placed um, uh, close to the far plane. So your spear is there, right? Are you able to see this, guys?
Yes.
Okay, it's working. Okay, good. So if I'm going to go 980 or spear, you cannot see the spear. So 980. So the spear, still you are able to see the spear, right? So 980. So it's not, it's gone. Okay. So let me move the spear to the original position so you can see the spear. So this is sphere dot position dot z is equals to 2, right? Okay, so this is the camera. So you have been using cameras a lot in your assignment without knowing how it works. Okay, let us try to add the zoom in and zoom out effect. Okay, in the main loop I'm going to add this. You can type the code along with me. So in the main loop, I think we have to add this in the main loop, or let me just check my perspective. Okay, let's try to add this. Okay, I think I have to add at the right position. So this is going to be the render loop, right? So we have to add here only. So camera dot FOV, okay, plus equal to, I have given what is add. So if you go to the code, add will be declared over here. Add is 0.01. So every time in the render loop, I'm incrementing by 0.01. So what I'm incrementing is the field of view, right? I'm incrementing, and you have to constantly update the matrix. See the projection. I will show you the projection matrix. Already this one is I posted this video by you because I like that professor from University of California, UC Davis, I guess. So he was deriving this, okay, this matrix. So we are if you have watched those videos, you will know that. So the projection matrix we have to keep updating for every render loop, right? So that is the projection matrix. I'm just camera dot update dot projection matrix.
What's in between FOV and add? Is that a plus and a minus?
It's going to be plus equals to add is equals to
plus equals.
Yeah, plus equals, or you can say camera dot FOV is equal to camera FOV plus add. Okay, so that's fine. Okay, so projection matrix, and if so field of view, right? Field of view. So if you have a narrower field of view where object is going to be smaller, right? If your field of view is going to be larger, then you are going to have the zoom out. You can actually, what I'm doing is I'm writing the code for zoom in and zoom out. Okay, so camera dot FOV, so greater than 100, or if it's less than 50, I'm just giving some arbitrary value. So I'm going to reverse the, I'm going to negate the add. So add star, I'm going to have, whatever is the value, I'm going to multiply with the -1. So we're moving the field of view back and forth. So just add these line of code. Okay. And camera position is set there. So let me just run this, see if it's works. Let me see if it's working for me. If not, I have to debug. Oh, where did I go? So are you seeing the changes?
Yeah, it's moving.
Yes.
It's moving back and forth, right? Zooming in, zooming out. Maybe in order to have a drastic effect, let's the 0.01, let's make it 0.1. So it is moving a little bit faster than right. So this gives an impression of so by changing the field of view. So I will show you my animation.
Oh yeah, it's moving now.
Okay, very good. See, a 0.1 was very slow. So you're moving back and forth. So this is how I'm moving, zoom in and zoom out effect. Okay. This kind of field of view, I did in Blender to have a, I can show you my, what is my channel? The other channel, YouTube. So this field of view I use for animation in Blender. My channel, where is my channel? Your channel. Okay. Maybe I'll show later. I don't know. Switch account. Okay, I have this here. So my
Does
video.
yours flip upside down?
Mine is.
Okay. When the when it changes to zooming out or zooming in, the
When
cylinder
it
and the sphere
starts zooming
flip.
in, it flips.
Yeah, it flips.
Yeah, mine does the same thing.
See in this log Kevin, this is the one. I mean, I also want you to. If I have time, I will also. I mean, I will teach in. I mean, this is I did in Blender, but you can write the code in Three.js as well. Okay, this one I did. So here also, I have the zoom in and zoom out effect. So see, zooming in and zooming out. Here also I'm playing with the field of view only. So it is coming close and then it is moving. I mean, it's actually moving inside. Okay, I have the zoom in effect and also I'm moving the camera's position also. So this has a nice effect, right? The same thing I did the code in Three.js. You can see that. Okay, so this is one thing. So are you able to do that, right? And see, let me just go to this code. Okay. Oh my god, you cannot minimize. Okay, I cannot minimize. That's fine. I cannot minimize. That's fine. Okay. So the camera position, where is the camera position? You can change the camera position. See, the camera is not actually following the target, right? The camera is, camera's position is set, you know, camera's position is set at 0, 10, 40. So this is the camera position being set at that position.
Not showing your screen, Dr. J.
I'm not sure. My screen is not visible?
No.
Nah.
Oh, sorry. Okay. I think what happened is that it stopped sharing when I minimized. Okay. Did you see the lock haven animation or you didn't see that?
No, we don't.
Oh, you didn't? Okay.
Oh,
I
is
saw
this
it
a,
we did
before,
see-
yeah.
Yeah.
Before this one, right? This one I was using field of view. Okay.
Yeah.
Now can you see that?
You see your code now.
Okay, very good. So this is adding this. Okay. Let me just show you. Let me change the camera position dot x. So here I'm not following here. I'm moving the camera position. So what will happen now? See, I've just changed the camera position now. It's not centered basically, and the camera is looking at. So if you have a camera, it's looking at some target. Here I'm not setting the target. We'll attach to the target in few minutes. But if I move the camera, see, I can move the camera 20 units, and see it is showing in different ways, right? So this is one thing. Let us add one more stuff, and so this is zooming in. And if you want to, this is, I don't know whether this link works or not. One of my students did for the project. Let me see if this is working. So this effect you can also create. So this is one of the student who wrote the OpenGL code. I hope it will come. So here we are also moving the camera. See how the camera has been rotated. It's 360 degree. It's been rotated, right? If you are having a car display model, you want to rotate the camera around the object and you want to show that object in three dimension in all the angles. For that, can anyone tell how to do this, to do that effect? Chantira, Beatrix? I want to move the camera. Can you see this? Here the camera is moving in a circular way, right? How do I move the camera in a circular way? Can anyone tell me how to do that?
Go to change x-axis.
Which axis what I want to change, Chantira?
X.
Just X? The X is correct. So this is a circle, right? In circle, at least.
You do like a degree thing?
Yeah, it's
like,
a degree thing. So what are the things? So this is Y, X, you are, so if, I mean, we also did this in the clock hand example, right? Where we have if you spin that in the, you know, y-axis is pointing upward and you are moving the camera in the xz plane, right? You are not moving the camera up and down. The camera is no, let me just draw it. So where is my pen? See, I don't know how to. So here we have axis. So this is x-axis, right? And this is z-axis, right? This is y-axis. If I want to move the camera, so I want to move the camera in which plane I want to move. I want to move in the xz plane, right? I have to update both x and z, right? Is it clear?
Yes.
Okay, so xz plane, right? So now can you write the code? It's not very tough. Let me write the code. You can comment this code because I just want to show you how can we do the field of view. Okay, and let me comment this, and also I think update, you have to keep updating the projection matrix. You don't have to, because there is add value was changing, so you are keep updating the projection matrix. So you can comment all these all these lines of code, and now we can write this. We know we have derived it. So now there is something called as I said, the camera has to look. When you move the camera is pointing in whatever way it wants. But if you want to shoot or point the camera at specific location, so there is something called lookat. Okay, this is in OpenGL, it's called GLU lookat is there. So similarly, we have lookat function, and here it's going to where we are looking the. So we are looking we are looking at the center of the scene, right? So new 3 vector, right? 0 0 0. So this is going to be the vector. So this is the camera lookat. So camera is looking at the center. Okay, and now camera dot position dot x. Here this is the radius. You know, you remember this x cosine theta and y sine theta, r cosine theta, r sine theta. So I think here we have to. So let me just put. This is the. So the theta is also declared. Okay, and sine theta are already declared in the function. So camera dot position, so is equals to. So theta is so every time what we are doing is, in the previous case we are incrementing the FOV, right? FOV only was updated, the use of add. Now what is updated is the camera, no, not the camera position. What is updated is the angle. So every time we are incrementing the angle, right? So let us do this.
Dr. J, should 3 vector be one word, or is that right?
Right. Sorry, I forgot. So this should be right. Thank you very much, Beatrix. This is 3 dot vector 3. Okay, I left 3 also. Okay. Thank you, Beatrix. So camera dot position dot. So this is going to be cosine of theta. So theta I declared. If you go to the code, I have declared what is theta. Theta to be begin with, let theta is equals to 0, right? So theta is equal to 0. I declared there. So what you are going to do is that you are going to increment the theta for every. So how many? Normally this main loop, how it's called? It is called. Can you tell me how many times this is called in a second? Around 50 to 60 times. We don't know exactly how many times this is called per second. So this main loop is a function. Is that clear? This is a function, right? And request animation frame. So this is rendering for, it's like this loop has been called around 50 to, I mean, I have commented it, see, 50 to 60 times per second. This is a infinite loop, right? So we always have infinite loop in computer graphics. But if you write an infinite loop, I mean, in event, this is all event driven programming. Okay, OpenGL is this is event driven. So where or the game engine is all event is going to occur in a loop. So there it is infinite. Okay, but traditionally we don't write infinite loop, but this is an infinite loop, right? So theta plus is equals to.
Is that adjustable to higher frames or no?
I don't think so. It's a very good question, but I don't think so. You can, but you have to. Actually, I don't know. To be honest, I don't know. In game programming, I did update my. I did call that I can call, but it is going to be 50 to 60, which is very standard. Okay. I don't think you can change that. See, the movies are played at 25 frames per second. And we can see a smooth motion because of the motion blur effect, because but here there's no motion blur, so here it is played at 50 to 60 frames per second. Then it leads to, I mean, we had one assignment where we rotate the teapot, right? In that actually it was updated, the frame rate was, so I think it was you can change that in that particular example. Look on to the teapot example where that was, I don't know what one. I can look on to the next class and can tell you. In that I was updating the frames. You can do that, but typically if you leave like that, it's going to be 50 or 60 times per second is going to be. That's a good question, Dennis. Okay, so add this and let's see if this code works. Okay, what you're supposed to so this is the code, that is, where is my code? Okay, let me open this again. So perspective camera, this is the one I am working on, right? So I made an error, I guess, so that's why it's keep coming as blank. Developer tools, where is developer tools? More tools, developer tools. I have an error. Math.sign is not a function, so I made a mistake in the function.
Has to be lowercase.
All these should be lowercase, is that right? Okay, very good, thank you. So this
Mine
should,
is lowercase, and I have the same issue where it's just a black screen.
Mine works. Yeah, mine works the same way.
so this is okay. I mean, there must be some bugs, but here it's the loop, it is twisting. So I mean, it is not twisting, it is rotating so fast, right? So I can decrement the value of add to 0.01. So now you can see that. Okay, someone has texted. Okay, this is that's the code for rotation. Very good. Now let me run. It is going to rotate more slowly. So this is a spotlight effect I am having. Okay, because I added the spotlight. If you remove the spotlight, let's say if you remove the spotlight, what's going to happen? So now I think the code should be pretty much easy to follow now. This is a very small code, right? So this is let me, what happens, you can add ambient light. Okay, you can look onto it. Ambient light is going to give you uniform light, but if I mean now it's going to become dark, the scene will become dark because there are no lights in the scene, so it's going to go. But if you have an ambient light, the whole scene will lit up. Okay, so and you can I think ambient light, I don't know, so you can check the document. Let me make this as a spotlight as an ambient light. I hope this will work, I'm not sure. Or you refer to the Three.js document. Okay, now you can see that ambient light is going to give you a uniform light. Ambient is a hack, as I said, okay, because we cannot trace every reflection that is going inside a room or whatever. We cannot simulate all light interaction. For that, ambient is a hack, right? So now see here, the object is not rotating. The camera is rotating around the object, right? Are you able to get this? Any questions, students?
Mine works.
Oh, okay, then that's fine. And then I just want to talk about the perspective. Perspective camera. perspective, you can know what is perspective, right? So perspective versus orthographic projection, you can Google and see how the object looks like. So in perspective projection, we have the frustum, or this particular example, you can see that, okay, someone has texted the shortcut. Okay, I forgot. Thank you. Control plus Shift plus J. Okay, developer tools. Okay, so in orthographic projections, all the objects are going to be the same size. So distance doesn't matter for orthographic projection. So this is useful only for building drawing, or building drawing, or maybe machine parts. You want to visualize this in, you know, different this one, right? So this is our, so you can, in this particular example, you can see that difference between the perspective and orthographic. So right, in this particular example, you see that the cubes get smaller and smaller as it moves farther away from the camera, but here the all these cubes are of the same size because distance doesn't matter for orthographic projection. Okay, Control Shift and I. Okay, I don't know when did, let me check. I forgot the developer tools. Let me close this. You are saying developer tools. I usually press F12 works for me. The developer, this one, right? F12 will launch. F12 on the keyboard will launch for me. Okay. Some people are saying Control Shift and J, and some people are still telling Control Shift. Whatever it is, okay, you can open that. You don't have to Control Shift and I. Okay. But F12 is working for me. The function key is working for me to open the developer tools. Okay. Now, so you know the, I mean, I will draw the basically okay. Okay, so what I want to tell, I just forgot. Oh, okay, I want to draw this. Okay, so this is the, so perspective camera you create like that. So orthographic camera, you have this box cuboid, right? You have a camera. So you have a camera, right? And I will draw, this is a cuboid. I hope I can draw this properly. So, I mean, so it is not a frustum and it's a cuboid. And so here we have near, this is the near plane. In the camera is located somewhere else. Camera should be in front of this. Okay, there is this. Camera is here. Right, camera is here. Right, camera is here. A near plane, and this is a far plane. And then we have right. This is the right. This is the left. This is the top. And the bottom is here. So these are the parameters for the orthographic camera. So you can write new 3 dot orthographic camera. So this is, I'm just writing, so orthographic camera. So this is the, you have been using orthographic camera first. One of the assignment, like placing the to, what is it called, forgot the name, you sunflower, you are using that formula. Yeah, what is it called, Vogel's formula. I think Vogel's formula, right? I forgot. And in that you are using orthographic camera, and if you do orthographic camera, you can see in the top, or you know, top view, you can see all this in this one. What I'm doing, this is left, so the parameters left, right, top, bottom, and near and far. Okay, so as I said, these are the parameters for the orthographic camera. So let us type this. Okay, let's not So here this object size is not going to change with respect to the distance of the camera. That is very important point to note. Okay. Let me, you can write the code along with me. So I think you can take the next, you save this code, okay? And you save this code and let me open the orthographic camera exercise. First, let us see how it looks like. So orthographic camera exercise, if you open that Chrome, so see here I placed I think how many 1 2 3 4 4 multiplied by 4 16 sphere. I placed 16 sphere, and again we are rotating the camera and the X Z. This is in order. This is a perspective camera. So in the perspective camera, see how it looks. So are you able to get this example running, guys?
Yes.
Okay, good. So now see, now let us create orthographic camera. Okay, open that. Let me close this one. Orthographic camera exercise. Okay, so this code is also easy to understand. So you have created staircase before, and one thing I just want to tell, I forgot to mention about the staircase assignment. So please do the staircase assignment and submit next week or using matrices. So the first assignment or second assignment, I'm not sure, we did an assignment on staircase, right? To build a staircase, now you have to build the staircase using only matrix. Actually you are now more proficient because already did the flower thing last programming assignment. So that's one exercise is remaining. So I think that will be the last assignment for this class. Okay, that staircase assignment. So please I will create the Dropbox and I will post the description in the Dropbox today. Now let us go ahead, Shuko.
A quick reminder, I don't see a Dropbox for the master students assignment. Yeah.
Okay, I'll do that as well. Okay.
Thank
Graduate students, I want the project. Okay. There are 3 graduate students. 1 student has updated. 2 students, please do. If you have any questions, please let me know. But your project is also important because your final exam is going to be 10%. And the remaining 10% is going to be for the project. Okay. I'll open the Dropbox for you. Okay. Now let us write a function, and so here also you can look onto this code and main loop. Let me write a function. You can type along with me. Okay. So let's switch. I will use switch camera. I'm going to switch between 2 cameras now. Okay. With this function. So here I'm writing camera. You can also type along with me. If camera dot instance of, I think over here should be capital. If the camera, let me just check notes. So this is not dot, it's instant of. Okay, and this should be in small letters. So camera dot instance of. So we are going to switch between 2 cameras. Now by default it's our perspective camera. Now I want you to create 3 dot perspective camera. Okay, and let me open this and let me type this. Okay, any questions? Please type along with me. We'll see if the switch camera. So camera is equals to new 3 dot orthographic camera. Okay, orthographic camera minus 300. So this is I wrote the parameters, right? So in the whiteboard, so this is left, right, top, bottom, near, far. Okay, this is my left, and my right is 300. This is left and right, and top is 400, bottom is minus 400, and this is my near, and this is my far plane. Okay. So what I will, if it's an instance of if it's an instance of perspective camera, we are creating a orthographic camera. So camera dot zoom is equals to 5, and camera dot update projection matrix. Okay, and else part. So what I am doing, if it's an instant of perspective camera, then I am going to create an orthographic camera. So new of 3 dot perspective. So if it's an orthographic camera, then I'm going to create a perspective camera. So this will be the usual. We will use field of view 75. And now I think I have that code. I will copy and paste. I don't want to type again. This is a whole code. Okay, it's already here. So this is the code. So type this code. Okay. Right. Type this code, switch camera. I wrote a function called switch camera. I'm saying that if that camera is an instance of perspective camera, then I'm going to switch to orthographic camera. Otherwise, I'm going to be here. If it's orthographic camera, then I'm going to be a perspective camera. So these are the. There should be a semicolon also, I guess, at the end. This is how you write the function in Three.js. Okay. I mean, it's not in Three.js. This is how you write a function in JavaScript. Let me check if this code is working or not. So this is working, so there is no error. I refreshed it. Developer option is going to be F12. If I type F12, then I can switch camera. See how this looks in perspective and how it's going to look in. And now I'm switching camera, right? So this is how it looks like in orthographic view. I'm rotating the orthographic camera, but you see that all the spheres are the same size. There is no distance, doesn't matter. But in perspective, I mean, if I switch back to perspective again, I can see that, you know, the farther the away, the sphere is smaller, and a near sphere are going to be bigger in perspective, right? Here the spheres are of different size. This is how we perceive in real world, right? So this is switch camera. Okay, so this is our orthographic camera. Are you able to get this?
Oh,
Yes, mine works.
Okay, I'll wait for some time. Next, I want to give you an exercise. I have the output. Let me show the output. Okay, first you do. I mean, if you are.
perspective cameras.
So camera is instance of 3. This is how the syntax should be. Okay. Right. Now I will have another exercise for you guys. See, this is my. I think. Let me open to the new folder. I have so many examples. Follow me exercise. So this will be the follow me. There is one file called as follow me, where you're going to follow the object. So I want to get this effect, you know, here we're following this sphere, okay, and this is moving up and down in the front, and I want you to get this effect, okay. But if you go to the original codes, I mean, if I go to the code I have not given for you guys, right? So if I go here, it will be looking like this. See, it will be, there is no camera movement, and there is nothing. So now you want to write the code so that it looks like the one like this. Okay, and this one I will take it for an exercise. Can you do this for me? Do you know how to do this? Try this. Okay, This is the end point. Okay. What I'm moving is that camera is looking at constantly at the sphere. Okay. The camera's look at is going to be the sphere position, and the sphere is moving in the YZ plane. Okay. So YZ is plane, and the cameras. Okay. Or I will write the code. We have time. We have 15 more minutes. Okay. And uh, open that exercise. We'll write that code now. One thing I just want to tell is that, Blender. So I will introduce you to Blender. Okay. We have 3 more classes. I will try to introduce to Blender, and we can. I will also try to teach you a little bit Python code in Blender. Okay. Possibly uh, the sunflower you are doing, right, that using the Vogel's formula. So we will write the code for that in Blender, and we can create that. I will do that in Thursday's class. So don't forget that there is a class on Thursday. So it's going to be all synchronous session. I'm not going to post any asynchronous videos or post videos from other sources. So this week we are meeting on Thursday. So please do come on at 4 o'clock. I will talk about Blender. So what I was supposed to tell about Blender is that you cannot work with Blender without the mouse. Today I posted the announcement that install Blender, but I didn't tell you to bring the mouse. Okay, so you need a mouse for using Blender. Okay, without this thing you cannot do anything concretely in Blender. So you have to have a mouse. So please bring mouse. In the next week we'll see that. Okay, not next week, sorry, this Thursday we'll see that. Okay, let me just write this code. So let me open that exercise. Follow where is that? Download. This is the one, right? So follow me exercise. So here I have created the spheres, and this code you can read. Added the sphere. Okay, we have a big sphere, and then we have a array of spheres. Okay, see, you have the code spheres and then big sphere. So we have created and we are added the big sphere. So what I want to, so how I got that effect is that, so in main loop you can write the function. So camera dot look at sphere position. So I am looking, so camera is looking at the sphere position. Okay, that's a big sphere. Let us run this code and see how that code is. It looks like this. Let me run this. So camera is just looking. It's not doing anything. So it's just looking at this. Okay, camera is looking at this sphere. Okay, this green sphere. So look at. Okay, and let me add more code. Sphere dot position dot. This one please submit for today's exercise, in class exercise. Okay, I want everyone to do this. Math dot sine of theta. Here I'm updating the y position. Okay, and sphere dot position dot z is equals to 20 multiplied by math dot cosine of theta. Now let me run this code and see how it looks like. The camera is not moving, but here there is a, okay, I didn't increment theta, right? So theta should be incremented. Theta plus equals to add. Let me see what happens now. So camera is looking at the sphere position. So the camera is looking at here, right? So the camera is looking at here, and then sphere dot position we are also updating. Okay, the sphere is updating, but I don't know why this set of sphere is moving. Okay, theta plus equal to add. Let me just write my complete code. Okay, so I hope you understand. So the camera is looking at this the sphere position, and the sphere y and z values are updated, and I think all the sphere positions Okay, create sphere. Okay,
It's probably the Z, or let me
If this is
play
in a
with it.
loop, if this is in a loop and you're incrementing theta, and then the sphere position, it's 20 times math sine cosine of theta, wouldn't that make the sphere move because you're in a loop? So it's doing this thing over and over again?
Yes, exactly. That's what it's doing. It's moving over the loop, and I'm updating theta, right? That if you don't update the theta, it won't move, right? So that's what it's doing.
But you don't want the sphere to move. Is that what we're trying to get to?
Yeah, I'm moving.
You want the camera to track with the green sphere.
Yes, we want the camera to track the green sphere, right?
You have to set the camera position equal to the same cosine sine.
Yes, you're right, Dennis. Camera dot position dot y is equals to sphere dot position dot y. Okay, and camera dot position dot z. So we are moving in the YZ plane. Okay, so that's why it's going like this. I don't know whether you can see me or not. It's going like this. Okay, in the YZ, Y and Z. You're not going in the XZ, right? You're going in the YZ like this. That's why it's going up and down. And camera dot position dot I'm locking the camera's position to the sphere position. So
You're going to want to, so if you do that, it's going, the green ball is just going to fill the screen because you're right on top of it. You're going to want to fudge it a little bit.
yes, you're right. Let us see. Okay, I'm experimenting myself. I'm just writing the code, and okay, very good. So because your camera is, because your whole green sphere is occupying, so we want to move the camera a little bit, maybe plus 5 units or plus 10 units, whatever you want to give, you can do that. And now you can see that you can see that, okay, before it was occupying the whole space, right? So this is how I got the effect. Okay, so this is the YZ plane. So if I want, I want to show you XC. I want to try how it is looks like XC. XC. XC is nothing happening. Only okay, it's happening. It's all this. Okay, this is, you have to, yeah. So all the spheres are moving, but this sphere is out of. So you have to adjust the camera. Okay, I just I will revert back, so I won't move in the. I want to. Sorry, getting this effect. This one submit in the Dropbox today. Okay, this is how you move the camera. You animate the cameras, right? So this is how you animate the camera, and the camera is tracking, targeting, and the sphere positions. Okay, position dot sphere position. What happens if I comment this code? Let's see if I comment this code, what is going to happen. Okay. Okay. I don't see much difference. Camera dot look at. So here it is looking. So I'm just looking at the camera. So just try and okay. You can see the difference. Just play with the code and see the difference. Okay. I just experimented this and I got this nice effect. I just want to tell you this one today. Okay. And then I want to tell you other one I was trying to do. Maybe I'll show you the next class. There's this folder. Panoramic view. So this is similar to the one of my student who did. So this is using texture, right? So we can create this. This is repeating the texture, and we can get this. Here also the camera is moving, right? The camera is moving, and I'm getting the 360D. So this is student exercise he did, right? So where he is rotating we have this nice, we apply texture here. It's not a empty space. Now we are similar to that what I created with the Lockhaven University. I created that, right? I have wrapped the textures. It's going to be this is something space. Okay, there is not empty. This is looking like a space or a sky or whatever it is. Okay, so please do submit this, and we will have a class on coming Thursday. As I said that please install Blender. So Blender interface, I just want to show you. How many have used Blender?
I have.
Patrick, Jason, okay. And who else? Have you coded in Blender? Did you write Python scripting in Blender, Patrick, Jason?
No, I use Blender for modeling. So I've made models and 3D designs and printed them and
Oh, you
stuff
didn't.
like that before.
You did with Darlene? You did it. You took a course on?
With Dr. Ferris Labar, yeah.
Yeah. Okay. She was mentioning. Okay. Yeah. Right. So how you can 3D print the? Can you create? Oh, you have. Okay. Jeremy also have used Blender. Patrick, Jason, you can. You created the sunflower, right? Is it possible to not the sunflower? Sorry, you created a flower for the last week programming assignment. Is it possible to print that?
If you could replicate it in Blender, yeah. You would. The Blender actually has a
STL format, right?
Right. And there's a helpful little add-on thing that's like enables you to it's like a little 3D print widget thing, so you can open the menu and have it check your vertices to make sure that they're all connected and that it's a continuous mesh, because that will screw up if you're trying to 3D print stuff and you have like a disconnected vertex and stuff like that. So there's actually a pretty neat tool set that you could get for Blender.
Okay, I mean I never used it. One of the student printed. Yes, if there is going to be discontinuity in the mesh, then yeah, you cannot print that. You have to have a continuous continuous surface to print, right? Okay, all right. So is Darlene teaching Blender or?
No, I learned Blender. I taught myself Blender. And actually I took a course in high school on Maya, and Blender is basically the free version of Maya, because Maya is very expensive.
Okay.
And so I just practiced with it and got better at it. And then when I took the intro to 3D printing with Darlene, I used Blender. She was teaching, I think it was like ZBrush and Tinkercad and stuff like that.
Okay, all right. Okay, I will teach you Blender. I cannot teach Blender in one class, or it's going to be taking a lot of time. Of course you know it, but for other students, I will talk about. So for Blender, please bring the mouse for the next class. Okay, so Blender will have how you cannot. I don't have a mouse myself, so I cannot rotate it. So you can rotate. So here is the camera, so you can view from the camera point of view. You have to use right select for selecting anything object on the scene, and we'll write small Python script on Thursday's class. And so how do you write Python script? You go to this menu and option, and then you have a scripting bar is there, and here you write the code here, and we will generate the sunflower pattern here. Of course you cannot print that sunflower. You have to put underneath something. You have to connect all the vertex, because it's all going to be. So I mean sunflower is the. See, sunflower is the one you generated, right? The spheres you Vogel's formula. That is actually the same code only. So where some of the balls will differentiate into, differentiate will means some of the balls will become like the petals for the sunflower. So exactly the same stuff. So, but instead of rendering as a ball, you will be rendering as a petal. Okay, and so we will write code here in next class. I'll teach you a little bit of Blender on Thursday's class, and also I have to teach you texture mapping, and so we will have 3 more classes. Okay, we'll do that on coming week. So please do submit this code and try to explore how you rotate the camera and how do you move the camera in Three.js. Okay, so and Blender is also fun. You can write code in Blender. So whatever code we have developed, you can develop in Blender as well. Okay. All right, guys, I'll see you on Thursday then. So please submit. I need only this code. Okay, the last code that I showed you. I will open the Dropbox. Okay, and I will try to also explain you how I created this one. Okay, this panoramic view how I created. I will try to explain you as well. Okay, I was 10 minutes late. If you can fix my attendance. Oh, sure. Okay, Freddy. All right. Jeremiah and Freddy, I'll mark your attendance. So please do submit this. Okay. All right. I'll see you on Thursday class. Remember, if um, okay. So I will post this video lecture. I will post this recorded lecture. I'll post this video lecture in D2L, and we will please install Blender 2.7 because I'm not familiar with the recent version of the when I interface. It will be difficult. So not difficult. I'm not used to it. Okay, I'm used to this interface. So we'll talk about Blender during the next class. Okay, we'll write some Python scripting in Blender on Thursday. All right. Okay. Any questions? You have to do one more assignment. Remember that your assignment is staircase assignment using matrices. Okay, I'll open the Dropbox for that, and for a graduate student, I'll open the Dropbox for the project. Okay, undergraduate student, don't worry about that. For graduate student, please submit that as this thing. You have only the due date for the this is for the graduate students. Okay, you have to submit your final project on the day of the exam. Okay, I will post when is the exam date also. Okay, we have one more week of class, and after that I will tell you what is the exam, and I may ask a programming this thing. Okay guys, thank you so much. I'll see you on Thursday.
Thank you, Professor.
Yeah,
Have a good one.
you too.
Yeah.
So it's just this rotating thing that we're turning in?
Yes, exactly.
Oh, okay. Thanks.
Yeah, okay.
Professor, I'm gonna show you my tree. I built it. I spent a lot of time on this.
Okay, can I see that? Okay, you cannot share, right? Let me stop
You
my